Hi everyone, we're going to look at how to perform a one-way repeated measures Anova or within subjects in Excel, and then how to write the results in APA format. So just a refresher, just know that you should, for an Anova, you should have the independent variable should be a categorical variable, and the dependent variable should be a continuous variable. And it gets a little tricky in with the repeated measures, and I'll show you why. Here's the data set we're going to be looking at, and basically this is job performance by individuals after they're tested repeatedly for 4 weeks straight. So they receive training, and then they're tested once each week. So they're repeatedly being tested. But if you look at the data, this all looks like continuous data. Well, this is the dependent variable, right? Their job performance levels each week. The category comes when we look at the times they were tested. So 1, 2, 3, 4. They're tested 4 times, 4 categories. So basically time is the independent variable, and it's counted as a category. Okay, so let's look at how we do this in Excel. So when you have collected your data for your participants, make sure that you have it laid out just like this. So if you're testing it the first time, you give each person's score going along, in a column, and make sure you have them in the same order. So for the next week, make sure that this person's score is matched with this person's score as well as this person's score. And to keep track of them, you should give them all maybe an ID, or maybe by their name, to identify them. So we're going to create a person, a respondent's ID for the first column, and we're just going to number them. So if I hit 1 and 2, I can start the sequence, grab it with this little handle in the corner, and drag it down to give everybody their number. And you need that here when you're calculating your results too. So now we have, everybody has an ID number. So for candidate 1, their test scores are here in week 1. Here it is in 2 and 3 and 4 and so on. So now to perform the analysis, you need to make sure that when you click on the data tab, you have this data analysis selector right here. And if you don't, you need to go to File, Options, select Add-ins, find Analysis Toolpack, select Go, and then make sure your check mark is in this box here and select OK. And then that button should become available to you. So now we're going to select the button. And so in order to do all this, first we're going to select the data we have. So click this little box with the arrow in it, and start with the respondent's ID number, or whatever it is you have them labeled as. It could be their names or some other number, whatever. And then highlight all of the columns and drag down. Okay, there you go. And now make sure you select the box there that says labels, because we did select the labels, and keep it at alpha 0.05. You can make it more stringent, 0.01 if you'd like, but typically we use 0.05. And now output range is an indicator where you can select where you want the data to appear at, and we have it selected for this cell here. But you can choose to have it open up in a new worksheet or even in a whole new workbook. Now click OK. And here is our output. So here it is giving you information for each individual person going across here. So it's actually spitting out information for between and within subjects. But we're interested in the within subjects or repeated measures, which can be viewed here is where these are the numbers we're actually interested in for now. And this gives you, if you look at the top, it gives you their mean and standard deviation. So here's the mean and standard deviation for week 1, 2, 3, and 4 for all of them. And this is the total number of respondents that we tested. And here are the actual statistics for the Anova. It gives you a comparison between the rows, or the people, and then the comparisons between the columns, and that's for the conditions each week, or their scores each week. And that is actually the one that we're most interested in at the moment, right? And it gives us the sum of squares, degrees of freedom, means, squares, then the F statistic p-value and F critical value. As you see, there's like a little e and a negative sign in the p-value here. That means it's such a large number, it's not giving you the exact number. So the way to get that to show up, because when we report our results in APA format, you want to know, typically you want to know exactly what the p-value was. So highlight that cell and select number. And now it's a very high p-value. So if you start clicking the little box here to the left, it'll increase the decimal points, and you can just keep going until you finally get to the number. And it's so large that in this case, we'll just go ahead and not worry about how many decimal points it is, and we're going to write it as p less than 0.001 because of the number of zeros that follows there. Okay, so now also when we're reporting in APA format, we also need to know what the eta partial eta squared is, and it's not providing that here in Excel. So it's really easy to calculate that. Just click in a box, hit the equal sign, and we want the eta square for the column. So highlight the sum of square box for the within groups, then the divide sign, and then the total, and hit enter. This is your eta square. And if you want to find the actual symbol for eta square, you can find that here in the Latin extended B subset. It's right here. It's this little n. So we're going to put it in there, insert, and then we're going to put in a 2. Oops. Oh, close that. And then we're going to put a 2. 2 is quite large, so we'll make it smaller. Maybe a little bit more. There. Looks more like an eta square. So that's the symbol for eta square, or you can just write it out, or partial eta squared. And now to put in our results in APA format. Your sentence would look something like this. A repeated measures Anova showed that for the 112 people subjects, tested on job performance for 4 consecutive weeks after receiving training, the difference in week 1, week 2, I should say week 3, oops, and week 4 were statistically significant. And then you put in the actual hypothesis test calculations, and the place where you get these the mean and standard deviation is found for each one. The mean and standard deviation are for each of the weeks here, and then for the F test, these are the degrees of freedom for the groups as well as the total number of people. So we had 4 groups. So n minus 1 for 4 groups is 3, and then we had 112 people, so it's 112 minus 1. And I believe it says it here as well. You can find it. Here's between the people, and here are the groups' degrees of freedom. And then you can also see here's the F statistic that comes next, right here. Then, if you recall, our p-value was very large, so we're just going to say p less than 0.001, and then we put in the partial eta squared score right here. And by the way, partial eta square is the effect size. So 0.72 is quite a high effect size, so our significance is not only a significant test, but it's also a very strong relationship between our groups. So apparently, receiving training in this case really helped individuals. All right, thanks for listening, everybody. I'll see you next time.